Good morning, respected sir. My name is Pujita Krishnan, and I am pursuing my second year in Electronics and Communication Engineering, Section B. My roll number is 21951A0477. I am pursuing my field in Institute of Aeronautical Engineering, Dundigal, Hyderabad. So today, I am going to take the privilege of presenting my TikTok presentation on the topic transfer resistor in the subject integrated circuits and applications. So today my topic is transfer resistors. So what is transfer resistor? Firstly, transfer resistor is nothing but it is also known as transistors. Transistor is actually the acronym of transfer resistor. So let us know about what is this. Before getting into a presentation, I would really like to thank my department for giving me this great opportunity as it helped me in gaining subject knowledge and also learn in knowing and getting aware many about many new things about this topic. So let's get into our presentation. So basically, let us firstly know what is transistor, what is resistor. So what is a resistor? A resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. The ratio of the voltage applied across a resistor's terminals to the intensity of current through the circuit is called resistance. So this relation is represented by Ohm's law, which is nothing but, as we all know, V equal to IR, whereas V represents voltage, I represents current, and R represents resistance. So let us know about what are the applications of resistor for the brief knowledge. So what are resistor applications? Resistors are used for limiting current in electric circuits, lowering voltage levels in electric circuits. It is used as current provider, as a sensor. Example, photoresistor detects light condition, thermistor detects temperature condition, strain gauge detects load condition, etc. In electronic circuits, resistors are used as pull up and pull down elements to avoid floating signal levels. So these are the uses of resistors. So let us move on to our next slide, which is says about what is a transistor. How is transistor defined as? So transistor, this is our main topic for today. So transistor is an electronic device which is made up of three layers of semiconductor material that can act as an insulator and a conductor. The three-layered transistor is also known as the bipolar junction transistor. So the first transistor in was invented in 1947. This is the transistor image which was invented in the year of 1947. John Bardeen and Walter Brattain devised the first point contact transistor. So let us know about transistor types. Transistor is broadly divided into two basic categories, that is BJT and FET. BJT is bipolar junction transistor and FET is field effect transistor. The BJT, that is the bipolar junction transistor, is further divided into two types, that is NPN and PNP. And whereas the field effect transistor, the effect is divided into two categories, which is known as junction FET and also known as MOSFET. MOSFET is nothing but metal oxide semiconductor FET. The junction FET is further divided into depletion mode, which is again divided into N channel and also P channel. Whereas MOSFET is divided into two categories, unlike the junction FET. So it is divided into two types, which is depletion mode and other one is enhancement mode. And this is also again further divided into two types, that is N channel and P channel. So let us know what are the applications of transistor. Transistor is an active component and that is establishing in all over electronic circuits. They are used as amplifiers and switching apparatus. As the amplifiers, they are used in high and low level frequency stages, oscillators, modulators, detectors, and in any circuit which needs to be perform a function. So these are the basic applications of the transistor. So moving on to our next slide. What are the history of transistors? In the year of 1906, an American inventor and physicist, Lee De Forest, made the vacuum tube triode or Audion, as he called it, which is used in radios and which is also used in early computers. So this is the basic construction of NPN, PNP, and basic planar structure. Epitaxial planar structure. So this is emitter, base, and collector, and this is how the diagram will be. And coming to NPN, it is divided into N, P, and N, three different diodes. Whereas one is base emitter junction, other one is base collector junction, and the middle one is base. And the top one is collector, and the below one is emitter. So this is about it. And the same way PNP is also in the same form. What are the regions of transistor? A transistor has three regions, namely emitter heavily doped, base lightly doped, collector which is moderately doped. And so these are the regions of a transistor. One is emitter, one is base, and one is the collector. But emitter is heavily doped, base is the lightly doped, whereas collector is moderately doped, as shown in this figure. Transistor symbols. So these are the transistor symbols, NPN, PNP. This is the transistor symbol of NPN, and this is the transistor symbol of PNP, PNP diode. And what are the types of transistor? One is BJT, UJT, FET, and MOS. This is the main categories of a transistor. So bipolar junction transistor is BJT and UJT is unipolar junction transistor. FET is field effect transistor. MOS is metal oxide semiconductor, as we have already seen in the previous slide. So what is transistor biasing? The base emitter BE junction is forward biased. The base collector BC junction is reverse biased. That is, it is formulated by the equation known as IE equal to IB plus IC. So let us know briefly about bipolar junction transistor BJT. A bipolar junction transistor or BJT is a type of transistor that uses both electron and hole charge carriers. In contrast, unipolar transistors such as field effect transistor only use one kind of charge carrier. For their operation, BJTs use two junctions between two semiconductor types, N-type and P-type. BJTs are manufactured in two types, NPN and PNP, and are available as individual components or fabricated in integrated circuits, often in large numbers. The basic function of a BJT is to amplify current. This allows BJTs to be used as an amplifiers or switches, giving them wide applicability in electronic equipment, including computers, televisions, mobile phones, audio amplifiers, industrial control, and radio transmitters. So what are BJTs? BJTs, the term bipolar refers to itself the use of both holes and electrons as charge carriers in the transistor structure. There are two types of BJTs, that is, as we already know, that it is the NPN diode and PNP diode. Operating regions of BJT. Cutoff, there are three, it's divided into three categories and three regions. That is, one is cutoff region, the one is saturated region, and the other one is linear region. So cutoff is having no flow. Intermediate current, controlled current flow is there in the linear region, and saturation region, full current flow. That is full on current flow will be there. So let us now know about unijunction transistor, that is UJT. The unijunction transistor, or UJT for short, is another solid-state three-terminal device that can be used in gate pulse, timing circuits, and trigger generator applications to switch and control either thyristors and triads for AC power control type applications. Like diodes, unijunction transistors are constructed from separate p-type and n-type semiconductor materials, forming a single, that's why it is known as or named as unijunction. P-N junction within the main conducting n-type channel of the device. And so now let us know about what is field effect transistor. The field effect transistor, FET, is a transistor that uses a electric field to control the shape and hence the electrical conductivity of a channel of one type of charge carrier in a semiconductor material. FETs are also known as unipolar transistors as they have involved single carrier type operation. The FET has several forms but all have high input impedance, while the conductivity of a non-FET transistor is regulated by the input current, the emitter to base current, and so has a low input impedance. Of FET's conductivity is regulated by voltage applied to a terminal, that is the gate, which is insulated from the device. The applied gate voltage imposes an electric field into the device, which in turn attracts or repels charge carriers from the region between a source terminal and a drain terminal. The density of charge carriers in turn influences the conductivity between the source and the drain. So this is field effect transistor, that's a FET, and these are the symbols of FET. This is how the symbols are there. The only difference between N channel and P channel is the gate enters into the diode here, and here the gate protrudes and comes out. It will be coming out. It doesn't go in. There's a difference between N channel and P channel. The arrows are in the different and opposite directions. So let us now know about MOSFET, that is metal oxide semiconductor, that is MOS. The metal oxide semiconductor field effect transistor, is a type of transistor used for amplifying or switching electronic signals. Short for metal oxide semiconductor, MOS is a method of creating transistors. MOS consists of three layers: a metal conductor, insulating silicon layer, and a semiconductor silicon layer. So transistor as an amplifier. Due to small changes in base current, the collector current will mimic the input with greater amplitude. A small change in base current amplifier equal to current gain. Large change in collector current. So this is the circuit diagram and this is the waveforms of the transistor which is used as an amplifier. So transistor as a switch. When used as an electric switch, the transistor is normally operated alternatively in cutoff and saturation regions. So these are the cutoff, that is the open switch, and this is the saturation, which is the closed switch. And these are the circuit diagrams. Transistor as a switch. Transistors are commonly used in digital circuits as electronic switches, which can be either in an on or off state. both for high power applications such as switched mode power supplies and for low power applications such as logic gates. Important parameter for these applications include the current switched, the voltage handled, and the switching speed categorized by rise and fall times. Future of transistors: molecular electronics, carbon nanotube transistors, nano inspiration wire transistors, quantum computing, CMOS device will add functionality to CMOS, non-volatile memory, optoelectronic sensing. CMOS technology will address new market macro electronics, biomedical devices. Biology may provide for new technologies, bottom-up assembly, human intelligence. What's human transistor technology? 3D transistor made using tri-gate transistors on its 20 nanometer logic technology. Advantage of tri-gate transistors: more than 50% power reduction at constant performance, 37 performance increase at low voltage, improved performance and efficiency. So these are the parameters, diode and transistors. So depletion layer, only one depletion region is formed in the diode, whereas in transistor, two depletion region are formed. The number of junctions are only one junction between a p-type and n-type semiconductor, whereas in transistor, two junctions are formed only in between emitter and base and other between base and collector. Terminals, two terminals are there in a diode, that is anode and cathode. Whereas in transistor, three terminals are there, that is the emitter, base, and collector. It is considered as a switch, whereas in transistor is considered as switch or as an amplifier. Applications are of the diode are the rectifier, voltage, double clipper, etc. Whereas transistor are amplifier, oscillator, etc. So what is common emitter configuration? Let us know about it. Point 1. The configuration in which the emitter terminal is common for input and output circuit. Point 2 is input base emitter, output is collector emitter. And this is the symbol and diagram of the common emitter configuration. Common collector configuration. The point 1 is the configuration in which the collector is common between emitter and base is known as CC configuration. Whereas point 2 states that the input signal is applied to the base terminal and the output is taken from the emitter terminal. And this is the symbol diagram of common collector configuration. So our last topic is common base configuration. What is it? Common base configuration is the configuration in which the base is common between emitter and collector is known as CC configuration. Point 2. It is input and output. Input is emitter base, output is collector base. And this is a symbol of the common base configuration. Thank you, sir, for listening patiently to my whole presentation. I hope you like my presentation, sir. It means a lot to me. I hope you would give me a positive feedback, sir. I'm expecting a good feedback from your side, sir. Thank you so much once again, sir. That's the end of my presentation.